This is an example of a piecewise-defined function. Usually we would just call this a piecewise function. So piecewise function, we have the name of the function f of x. F of x is equals to multiple pieces. So in this function, we have 3 pieces, and then each piece has its own domain. So for example, f of x equals to negative x minus 4 is a linear function. This linear function lives when x is less than or equal to 0. So let's graph that. Negative x minus 4, so we have a y-intercept at negative 4, right? So we have a y-intercept at negative 4, and then the slope is equals to negative 1, so which is decreasing, right? So decreasing negative 1, then this is what we do. So decreasing at negative 1, and that's it. So how do I know the slope is equals to 1? Well, you do the rise over run. So 1 units down, and then 1 units to the right. Okay, there you go. Oops. Let's put this back. Okay. I should start this all the way in the center, right? Okay, that looks way better. So this is negative x minus 4. And then the next one is y equals to negative 6 when x is between 0 and negative 5. So negative 6 is where? Negative 6 is, let's match the color. Negative 6 is like down here, right? Negative 6 when x is between 0 and 5. So this is 4, and then this is a 5. Now, here is a question. How come one end is an open circle and then the other end is a solid circle? The previous piece, we have x less than or equal to 0. So equal to 0 means this is a solid circle. We have x less than 5, there is no equal, so that's why I use an open circle. And then when x is equals to 5, there is an equal, then we use a solid circle. Now, what happens if I put a solid circle in here? If you put a solid circle in here, then this is not a function anymore, because when x is equals to 0, you get 2 different y values. Remember this? When you input an x, you get one unique y. That means you press a key on the domain side, you get one light on the range side. So in this case, if you make that circle solid, when you press a key, x equals to 0 on the domain side, you get 2 different lights on the range side, which is negative 4 and negative 6. So that makes the function fail completely. So because you can, every time you put one x in, you get one y only. So this must be an open circle. And then the last piece we have 3 over 5x minus 9, right? And then when x is greater than 5. So when x is equals to 5, what do we get? When x is equals to 5, so when x is equals to 5, we have 3 minus 9, which is equals to negative 6, all right? And then that means we start right over here. We start right over here. And then for the domain, what's the domain? I mean the slope. The slope is 5 units to the rise over run. So that is a 5 units to the right, and then a 3 units up right there. So that means for the next piece, the piece goes up like this. You have another point right over here. The piece goes up like that. And then now, so let's just erase this extra stuff. So this is the graph of the piecewise function. Now let's do some evaluation. Okay, so the first piece is what? The first piece is f of negative 7. Okay, for f of negative 7, so when x is equals to negative 7, which piece should I use? First, second, or third? Negative 7 is less than or equal to 0, then we use the first piece. So f of negative 7, that is equals to negative 7 minus 4. 7 minus 4 is equals to 3. So when x is equals to 7, like that, y is equals to 3. So therefore, we have a point right over there. And then how about x equals to 0? So this is x equals to 0, right? Then we still use the first piece. So f of 0 equals to negative 0 minus 4. We have a negative 4. So therefore, we have 0, negative 4 right over there. And then the next piece is when x is equals to 2, that falls into the second domain, the second piece. Then we follow the color code when x is equals to negative 2, or 2. When x is equals to 2, then y is just equals to negative 6. So this is y equals to negative 6. And then how about phi? Phi is here, right? There is an equal. So when x is equals to phi, y is also equals to negative 6. So this is a phi comma negative 6. And then how about the next piece when x is equals to 8? So when x is equals to 8, 8 is greater than 5, then we use the last piece, and then that is a f of 8, which is a 3 over 5 times 8 minus 9, which is equals to negative 21 over 5. And how about when x is equals to 14? So f of 14, that belongs to the last piece as well. Then you have 3 times 5, and then times 14, and then minus 9. Now, there is a what if. Like what if I change the last piece, so if the last piece is f of x equals to 3 over 5 x minus 9, and then this one they change that to 5 greater than x and then greater than or equal to 10. What if they do this? If I still ask you to evaluate f of 14, in this case, if I change the domain to that and I still ask you to do a f of 14, then this is undefined. Because x equals to 14 is out of the domain. That's why. Okay, so that is the end of this video. If you like the way I explain piecewise function, give me a thumbs up and I will meet you all in the next video. Signing out.